Hey everybody, my name is Stephen Feuerstein. I'm the Oracle Developer Advocate for PL/SQL and actually lead a team of developer advocates who focus on helping our users get the most out of Oracle database in this modern era of application development. There's my email address, my Twitter account, my blog, my YouTube channel. Feel free to follow me, ask me questions, and get the most out of PL/SQL through my experience. And my experience is rather a long one. I started with Oracle in 1987, worked there for just short of 5 years, then left to do consulting and, I wrote a book. And then I wrote 9 more books on PL/SQL, and pretty much since 1994, I've been doing nothing but obsessing about the PL/SQL language. Hopefully you can benefit from my obsession. Back in 2014, I rejoined Oracle, and I'm now working there actively building PL/SQL code and building sites on PL/SQL and doing trainings like this one. So what I'd like to do for the next hour or so is discuss how to do impact analysis. In other words, you make a change in your code or your data model. What will that do to your code? How big a change is it? How many programs will I have to change, and so on? And we'll take a look at answering those kinds of questions with a feature called PL Scope, which was added in Oracle 11g and was enhanced mightily in 12.2. Now, this slide shows you many different resources for Oracle database developers. In other words, people like you who write SQL and PL/SQL. I'm not going to go through all of these in great detail or explain or show them, but first off, we have the PL/SQL landing page. In other words, it's our go-to place to learn about the PL/SQL language. We've got the historic and highly regarded and very busy forums on SQL and PL/SQL topics. Bryn Llewellyn is the PL/SQL product manager, and he has a blog that covers both PL/SQL and addition-based redefinition. EBR can be used to have zero or almost zero downtime on your applications. The Oracle Learning Library is a tremendous resource offering videos and Oracle by example and tutorials and MOOCs, massive online open courses, on many different Oracle technologies. The Dev Gym, one of my favorites since I manage it and build it, maintain it, is a platform for taking quizzes and classes and workouts on SQL, PL/SQL, database design, logic, and more. Ask Tom. I expect you've heard of Ask Tom. It used to be the place to go to ask Tom Kite questions. Tom is now retired, and I'm very pleased to say that 2 members of my team, Connor McDonald, who lives in Australia, and you've probably seen on this program already, and Chris Saxon, who lives in the UK, as well as Maria Colgan, are the new Ask Tom Answer team, and TOM now stands for the Oracle Masters. So do visit Ask Tom and ask your questions. Live SQL is a fantastic resource. It offers 12/7 access to a 12.2 database instance in which you can play around with SQL, play around with PL/SQL, and also access a script repository. That will be my main vehicle of showing you examples of PL scopes tonight. I'll be showing you things on Live SQL. OracleDeveloper.net and OracleBase.com are 2 websites from non-Oracle employees that offer great content about all things SQL, PL/SQL, and Oracle database. So do check those out as well. So, PL Scope. PL Scope was first added in 11g Release 1, and it's a compiler-driven tool that collects information about identifiers and statements in your code. In other words, all the named objects in your code and the SQL statements, and it stores that information in data dictionary views. So why would you use PL Scope? Well, first of all, what I'm going to cover in this section are the questions you can answer prior to 12.2, since many of you may not be there yet. And then I'll talk about how with 12.2 you have some amazing new capabilities. So with PL Scope as of 11.1, 11.2, 12.1, you can answer questions or get answers to questions like, where is a variable assigned a value in a program? What variables are declared inside a given program? Which programs call other programs? Find the type of a variable from its declaration, and much, much more as you're about to see. Now, you might look at those questions and say, what's the big deal? I can open up my code, I can do a query against all source, and I can just do searches, do text searches in my code. Well, think about for a moment the idea of where is a variable assigned a value in a program? That's kind of a hard question to answer. For example, it could be a select into, it could be a bulk collect into, it could be an out parameter, it could be an in-out parameter, it can be an assignment, it could be a default value in a declaration. There are many ways that a variable can be assigned a value. So when you run your code, you run a test, and your variable is set to null, and you look at your code and you say, how could this be? my value should not be null anywhere. Where is it being set to null? You can use PLScope in a static and analytical kind of way to identify those 15 places in your code where this possibly could have happened. So that's just to give you a little sense of the depth of this tool. Now, all the code I'm going to show you today are available in one of two places. One is at livesql.oracle.com, and you'll be seeing that soon. And the other is in my PL/SQL learning library inside OLL, so oracle.com/OLL/PL/SQL. And you can then download the demo zip file. But I encourage you first and foremost to start to use LiveSQL. You'll soon see how valuable it is. So life without PLScope, going back to some of my comments on the last slide. Before PLScope was available, and even today, if you're not aware of it or not using PLScope, if you wanted to analyze the potential impact of changes to your code, I'm going to add a new column. I want to remove this column. It's an old column. It shouldn't be used anymore, and so on and so forth. All you could really do were text searches through a data dictionary view like all source, in which I could say, find all the lines of text that are like something else, or I could even do much more complex regular expression searches and so on. You could also ask the all dependencies view to give you information about dependencies. You can say, for example, find all the packages or the database program objects that reference a certain table. And that's great. That's a great thing to be able to ask. The problem is that it doesn't give you very granular information. So for example, what you can say is find all the packages in my application that do inserts into table X, or find all the packages that reference a certain column in table X. Because number one, the dependencies view doesn't track the kind of access to that table, just the fact that it's dependent on it. And second of all, it doesn't handle that level of granularity below the database object. Now, it's good to know, and hopefully you're aware of this, but if not, I'll make you aware of it right now, that as of 11.1, Oracle does now implement fine-grained dependency information. In other words, when you compile a program unit in the database, it not only keeps track of the fact that you referenced table X, but it also keeps track of the fact that you referenced column Y in table X. And it uses that information to reduce the amount of times that dependent program objects need to be invalidated. So for example, if I change the data type of column Y from number to varchar2, and your program doesn't touch column Y, your program will not be invalidated, which is really nice. But from the standpoint of impact analysis, it's not so great because this information is not available in the data dictionary views. That level of granularity is not available to you through all dependencies or any other data dictionary view. So that's where PLScope still can come in very handy. But it's great to know about fine-grained dependencies, and particularly the tip to keep track of here is that fine-grained dependency analysis is greatly aided if you make sure that whenever you write a SQL statement inside your PL/SQL code, inside the SQL statement, you qualify references to every column and every variable. So the column, you can put the table or alias name in front of. The variable, you can put the name of your program unit in front of, like create or replace procedure X, and I pass in parameter Y. Inside the SQL statement, you can say x.y. And the more you do that, the more you fully qualify your SQL statements, the even fewer times that your program units will be invalidated. Doesn't have anything to do with impact analysis, but I hope you'll agree it's a good thing to know. So life without PLScope, you can do impact analysis, but it's fairly crude and you're very limited in the extent of the details that you can get out of your code. This is an example of the kind of query you might write against all dependencies. So this is finding all the objects that reference a table or view, in a specific table in this case. And it's a good way of understanding how many different packages reference your tables and how you might want to narrow down those references to a relatively few packages. But in any case, it's still fairly limited in how much value it will give you. All right, so let's get started with PLScope. First of all, by default, PLScope is disabled. So PLScope must be enabled in your session. It's turned off by default. And it's really easy to set through SQL Developer. We have a screen to do that, and I'll show you that on the next slide. But in general, once you've turned on the gathering of identifiers, and with 12.2, you'll see a little bit more here, not only identifiers, but statements. But once you turn on PLScope, then every time you compile a program unit, information about all the identifiers in that program unit, essentially everything with a name, will be written to the All Identifiers view. Once it's been populated with that information, you can write queries against the view to get information about your code. You can also check the All PL/SQL Object Settings Data Dictionary view to find out what your PL scope setting is. And you can in fact find out all of your compile time settings. What are my warning settings? What optimization level is this program unit set at? All of that is available through All PL/SQL Object Settings. Here's how you turn it on in PL scope. So if you choose your preferences, select preferences, then go to database and compiler, or just type the word compile in the filter, you'll come right to this page. And in this page, you've got a number of really useful things. First of all, you can set warnings. And I do want to spend a moment on this because very few people take advantage of this feature. So this whole top section is all about warnings. The warning subsystem added in Oracle 10G gives you feedback on the quality of your code. In other words, your code might compile, but it could have some pretty bad problems in terms of performance or bad practices in the way you've written your code and so forth. But what you can do is turn on warnings, and every time your program is compiled, you'll see a list of warnings from the PL/SQL team. These are things you should fix in the bottom of your screen in SQL Developer and pretty much any UI working with PL/SQL. Now, here's my recommendation. Turn on all, enable all warnings, and then for severe warnings, override them as compile time errors. Now, you could make everything errors, but it's not practical for a number of reasons. But this way, you get warnings about everything that the PL/SQL team thinks is important, and your code will literally not compile if it's got a severe warning in it. So that's what I do in my code, and it's definitely improved the quality of my code as a result. Additionally, on the screen, you can set your optimization level. By default, it's 2. The PL/SQL team suggests that you raise that optimization level to 3, which is a new feature added in 11G Release 2. And this will improve or could improve the performance of your code further. So set your optimization level to 3, turn on your warnings, okay, and now it's time for PL scope. Well, that's easy enough. Just set it to all. You don't have a lot of options here. It's either all or it's off. So make sure that your PL scope identifier setting is set to all inside SQL Developer or your other tools. And then every time you log in to the database and do your code, the identifier information will be gathered. Excellent. So you've got PL scope going. What are you going to do with it? Now, the objective of my talk today is not to give you in-depth knowledge about all the aspects of PL scope and the all identifiers view, because as you're about to see, there's a lot there. What I want to do is get you excited about the possibilities and point you to resources to help you leverage this after we're all done. So at a high level, some of the most important columns in all identifiers are the following. First of all, the type of the identifier. Is it a variable, a constant, a procedure, a function, etc.? What is the type of usage? So is this the definition of the package? Is this the declaration of a variable? Is it where there's assignment? Is it a reference to an exception, and so on? The line and column in your code in which the identifier is found, but not the text. So commonly you will join all identifiers to all source to get the actual text based on this other information. Really importantly, we have the signature. So the signature is a unique value that's generated by PL scope for every single different identifier in your code. Now, this is really critical because, as I'm sure you know, you can have multiple packages that have the same names for programs inside them, procedures and functions. You could have inside a single procedure a declaration of a variable that the same name is used over and over again in different blocks and subblocks and nested blocks in that procedure. So just having a same name is not particularly useful when you want to track usages across your code base. So instead, you have a unique value for every identifier, and you can then use this signature to distinguish between different overloadings of the same program, in other words, the same name, and connecting up subprogram declarations in packages with definitions in the package body, and basically tracking usages through your entire code base. And finally, we have usage ID and usage context ID. Essentially, you can think of these as like employee ID and manager ID. The usage context ID is the parent of the usage ID. So for example, the variable is declared inside a block. So the procedure would be the context for the variable that's declared inside of it. Alrighty, so that's a rough idea of some of the key columns. Let's take a look at some different usages. So I'm going to run through a number of examples, essentially by going over to Live SQL and showing you the things that you can look up yourself, you can do yourself after the session is over. So show all the identifiers in a program unit. Just print this stuff out for me. What have I got? Show all the variables declared in a subprogram. Show me all the variables declared in a package specification. That's an example of a QA script. And it's one of the ways in which you can use Live SQL to improve the quality of your code. And I'll explain why I think that's important in a moment. Show the locations where a variable could be modified. Now, rather than show you all these individual files in SQL Developer, let's go check out Live SQL. So I'm going to switch my screens for just a moment. Okay, so this is Live SQL, livesql.oracle.com. And once you log in, and let's make sure I have a live connection here. Once you're logged in, you can first of all write your own scripts. I can say, oh, I want to try out some new analytic stuff. I'd like to see what Max does for me. So select Max, hire date, HR.employees, script. And there you go. So if you have folks in your organization who are not that familiar with SQL or PL SQL, this is a great place to send them. So they can just play around, they can write stuff. There are tutorials they can try out. And there's also the idea of a code library. So for example, if I click on code library, I can now search through all these different scripts. Let's get rid of my PL scope. And there are just hundreds and hundreds of scripts that you can try out. So for example, Hello World, I can click on a script and I can say, let's run it. And it worked. And then you can take this and you can play around with it, change it all you want. So what I'll do is go home and I'll search for PL scope. And then what you find are a number of scripts, mostly that I've written, though I think there's at least one from others. And you can just click into any of those and play around. So PL scope examples. So as you can see, I'm creating a copy of the HR table for my own. I'm going to turn on PL scope. And then I'm going to create some program units that I can use to apply PL scope to. So since I've initialized, I've turned on PL scope here. Whenever I compile these units, it gathers the information about these program units. All right, so I've created a package. Here's an example of using the usage ID and usage context ID to show the hierarchy of identifiers. So I've created a subquery. The with clause allows me to create an inline subquery, a really fantastic feature. If you're not already doing this with your complex SQL statements, I strongly encourage you to do so. It allows you to essentially do top-down design, modularization of SQL. Pretty amazing stuff. So what I'm going to do is grab all the information from the user identifiers view in this case for a particular object. And then I'm going to select from that, and I'm going to use my connect by start with syntax to say connect by the usage ID with its parent. And then of course use my good old level value to do my indentation, and here we go. So I've got a package. It has within it a procedure. It has within it several parameters. Those are called formals, formal parameters. I've got an in fact, they're all ins. There's the name of the parameter. That's where it's declared. It references integer as a subtype. That's the data type of the parameter. Notice here I've got a formal, and it references table.employees.lastname%type. What you're seeing here is the new enhancements in 12.2 that actually track the table information, which it wasn't doing before. So that's very cool stuff. So I can say, find all the declarations that rely on the employees table. I've got a constant, I've got a variable, and so on. And you can see all the different ways that it's used. Now, here's an example just to start playing around. Here's another example of how you can do some pretty interesting stuff with PL scope regarding naming conventions. So I bet all of you have naming conventions in your organization. So for example, for me, when I declare a program unit, a procedure, or a function, and I define parameters, my approach, my naming convention is that in parameters end with _in, out parameters _out, and in out parameters _io. Now, everybody's got different ideas for naming conventions. Some people like to put p_ in front of their parameters, and not have the mode in their parameter. So that's okay. I'm not asking you to buy into my conventions. Here's the point though. If you can express your conventions as a pattern in SQL, and it would be very surprising if you could not. In fact, if you cannot express your naming conventions with SQL patterns, then you should get new naming conventions. And what I'm going to do here is query against my data dictionary view. I'm going to look for all the parameters, so parameter type, formal in, or the object type. The identifier type is a formal, in, out, or in, out. I'm going to look for their declarations. And then I'm going to find out if the parameter name is not like this, if it's in, not like this, if it's out, and so on. And I can immediately get information back about violations of my naming conventions. Now, how cool is that? For the first time, built into PL SQL itself, whether or not you've been able to do this in some third-party tool, you can now construct your own job. You can run it nightly against your data dictionary, your code, and you can find out all the violations of naming conventions, send out an email to all the developers who are violating those naming conventions. You can actually get some consistency in your code that you've never been able to do before. I think that is very cool. And here's another example of showing the signatures. So I'm getting all the identifier information in my demo procedure, and I'm getting the signature. There's nothing particularly interesting about them, except to be really clear, they're all unique. So if it's the same identifier, it's the same signature. Even if they're different usages, here's the definition versus the declaration, but this is the same thing. Okay. Let's take a look at this one. Now here's an example of something else that's really interesting in terms of analysis. Find me examples of code that I've declared but have not used. So first of all, here's a program unit that declares an exception. Hopefully you know this, you can declare your own exception. You can associate that exception with an error number, either something in the minus 20,000 range for your own application errors, or even one of the Oracle error codes. Maybe Oracle hasn't given a name to an error code that you want to reference and you don't want to hard code it, which is a really good idea. I can raise the exception, I can handle the exception, and so on. So I do the declaration, and what you can see here are the different kind of information you get from identifiers for exceptions. So there's the declaration. Well, that makes sense. Here's the assignment. Now, what is an assignment for an exception? It's when you associate a number with your user-defined exception, and then you can reference them either with the raise or the when. And then let's take a look at declaring exceptions but not using them. So I've declared two different exceptions, eBadData, eBadData2, but I've only used BadData2 and not eBadData. So what I'm going to do is, again, using my with clause, I'm going to declare an inline view that gets me all the information, all the identity information for exceptions that are declared. So that should give me two, eBadData and BadData2. That's the name. And then I'm also going to get all the references to the exceptions in my program units. Name, type, and name. And then I'm going to minus one set from the other. So everything I've declared minus everything I've referenced. And lo and behold, eBadData, not in use. Now the compile time warnings will also give you feedback on different elements of your code that are declared and not used. But this gives you, I think, a much more comprehensive view that you can extend to all sorts of elements inside your code. Now let's talk about package level variables for a moment. Let's go back up to the package. Where's my package? There we go. So I've created a package called PLScope demo, and it has a public global. That means public means that it was declared in the package spec. And that means that anyone with execute authority on this package can call these procedures and functions and also reference this variable. Now, there's nothing necessarily wrong with declaring variables, certainly constants, in your package spec. The thing to realize is that when you declare something in the package spec, you lose control over it. Anybody with execute authority can modify the value of this variable. There are no controls. That's why many programmers talk about get and set procedures and functions. So create a procedure to set the value, create a function to get the value to protect that variable. But it can be done. You can have variables here. And with PLScope, you can very easily follow the variables that are declared at the package level. So a very simple query gives you this kind of information that would otherwise be difficult to do and identify vulnerabilities in your code. And notice I'm doing a search for a type equal variable. Type equal constant is fine because, of course, you can't change the value of a constant. And that's a very common technique. Alrighty, so there are a few examples. Let's go back to the slideshow. More advanced examples, I believe I've actually covered all of these as well. Exceptions defined but never raised, the hierarchy, and naming conventions. So let's keep on going. Now, one thing you're going to find with PL Scope is that it can be hard to get a handle on all the queries you need to write and the different ways of understanding the all identifiers view contents. So one of the scripts you'll find in PL Scope is a helper utility, a package that I built that kind of bundles up some of these queries into a single package API, allowing you to access or understand them more easily. On the last slide of my talk, I'll also point you to some other resources that are even better than my helper package. But don't be surprised if you start to work with PL Scope and you get a little bit overwhelmed. So take full advantage of everything that we built into LiveSQL and other resources for you. All right, let's get on to the really interesting stuff, which are the 12.2 enhancements to PL Scope. Now, for all that PL Scope was great in 11G and 12.1, one of the big problems that I had with it is that it didn't help me out with some of the bigger questions I've got about my code, which essentially is how I use SQL inside PL SQL, which means more specifically, how do I reference and manage the underlying tables in my database through my PL SQL code? And I'm sure you've all been around Oracle database long enough to know that you can write some really great PL SQL code, but if you're not careful about how you write the SQL, it can turn into a god-awful mess. So being able to get some understanding about how SQL is being written in your application and how this logic is spread across your code base is really important. But again, prior to PL Scope and prior to PL Scope 12.2, all you could really do were text searches and some basic dependency analysis with the all dependencies view. No longer the case. So as of 12.2, in addition to turning on identifier analysis, you can say track information about statements as well. And this will populate a different view called all statements, but essentially you use all statements and all identifiers or the user version for your specific schema together. So now you can ask all sorts of even more interesting questions. For example, you can find where specific columns are referenced in your code. I want to know all the places where the employee hire date is referenced, not some other table hire date, not some variable named hire date, the employee table hire date. Find all the programs performing specific DML operations. For example, find all the places that perform an insert on my table. Now, I'm a strong proponent of building APIs around my code. And what that means is that the objective should be that for every table, for every insert into that table, it should appear just once in my code. There should be one insert into the employees table. It should be inside the insert procedure or some business entity on top of the insert. For example, add employee that does an insert into the employees table and perhaps sets up some history information. But the bottom line is that if you're having a problem about how the data is being inserted into your table and values not being right, rather than have to look at 25 different inserts across your application, you should be able to go to that one procedure, add tracing, and get the information, get your answers very quickly. So find all the places that specific operations occur so you can consolidate such statements. Find all the SQL statements containing hints. So as I'm sure a lot of you know, you can add the /* comment in your SQL statements and inside your PL SQL code to give hints to compile the cost-based optimizer. Now that sounds like a great idea. The problem is that something that works well as a hint in 11.1 might slow things down in 12 or 12.2. So you might find that it's very worthwhile every time you upgrade your code to look for all the SQL with hints and maybe turn them off and see how things work without those hints. All dynamic SQL usages. So hopefully none of you have been involved in a SQL injection attack in which your code has caused your company to lose information and have data corrupted. But the way that will happen is through dynamic SQL operations. Static SQL never is a SQL injection vulnerability. So it'd be awfully nice to be able to say, find all the places in my code where this vulnerability could occur. And now with PL Scope, it's quite easy to do that. Find the locations in your code where you commit a rollback. Find multiple appearances of the same SQL statement. This is definitely one of my favorites, and I'll show you an example of that in Live SQL, and we'll talk further about it. And here's another good one. Find all the SQL statements that call user-defined functions. Let's take a closer look at a lot of these. So as I said, in addition to the all identifiers view, there's now an all statements view. And the all statements view gives you information about your SQL statements, which is different, of course, than your individual PL SQL identifiers. So it includes the full text of the SQL statement. It tells you whether or not you're doing a collect into a PL SQL record, if it uses current of syntax, if it uses the for update syntax, whether it's a bulk collect into, and then it's got a usage ID column as well. It essentially ties into the all identifiers view based on the usage ID. And the SQL ID points to the SQL statement in $sign views. Here are some examples. Remember I talked about what happens if somebody, let's say you've run in some consultant who said they really knew SQL very well, and it turns out, well, they didn't. And what they did was compensate for their lack of skills around SQL with lots of hints. And now it's messing up your performance. This is all you have to do to find out all the SQL statements that have hints in them. And then you can join this to all source, and you can find the lines in your code, and boom, single report, and you're done. Find all the DLML statements on a table. So here I'm going to join all identifiers with all statements and all source. I'm going to find references to tables, and I'm going to join across these different views, and I'll use my hierarchy to find the things that own these references and then display them. More examples. So the same SQL statement used more than once. Now, hopefully you know that Oracle does a lot of optimization in your code, and it does it specifically to improve performance. And in this sense, regarding SQL statements, if you pass a SQL statement to the database engine for processing, the first thing it will do is ask, do I need to hard parse the SQL statement? Hard parses are relatively expensive. So we want to avoid that whenever possible. And one of the things that the database does is takes your SQL statement and hashes it into a number and looks to see if another string with that same hash value has already been parsed. It's a very fast check, but it also means that it's a very crude check in that if there's even the slightest physical difference between your SQL statements, it'll treat them as different SQL statements. Let's just jump right over to Live SQL to show you this instead of me talking so much without showing you anything. So find duplicate SQL statements with PL scope. You can see that I've turned on both identifier gathering and statement information gathering. Here's my SQL statement. Now, here, in fact, are two SQL statements. So as is very common in many development organizations, everybody has their own style. So Sandra likes to use lowercase for all the keywords and use lots of different white spacing. And I've got a different approach. I like to uppercase my keywords. I like to right justify the keywords in them and keep things more compact. Now, the interesting thing here is that even though these are physically different statements, and if I executed these SQL statements outside of a PL SQL program and put them inside SQL+, they would be two physically different statements. And that means that they would both be hard parsed. But interestingly enough, if you put the same SQL statement inside PL SQL, then when this code is compiled, the compiler looks for static SQL statements and it canonicalizes them into a standard format. So all the keywords are uppercased. All the extra white space is gone. It's just one single long line without any additional white space in it. And that's what gets passed to the SQL engine for hashing and parsing analysis. And what that means is that, interestingly enough, these two statements turn into the same physical statement. And I'll show you that now by saying, well, okay, I've created those two procedures. I've gathered my SQL information about them. I'm going to get the SQL information from user statements. So get me all the SQL statements for these two procedures. Take a look. Exactly the same. And notice the same SQL ID. Now, this is an advantage, right? This is a great advantage to putting your SQL statements in PL SQL. And it's a great reason for you if you have conversations with JavaScript developers and Java developers in your organization, and they say, we don't want to have anything to do with the database. Leave us alone. We'll just read and write rows and keep it as simple as possible. One thing you should tell them is that simply by taking those SQL statements out of their Java code and putting them into PL SQL code, you get enormous optimization potential. So that's one thing about the process of PL SQL and SQL. The other thing, though, is that you might have lots of different SQL statements all over your code base that are exactly the same. You don't want to have repeated SQL statements that are the same, because then if one of them has a bug, you have to find all the other matches and fix the bugs in those. Or if you want to change the functionality or an enhancement, you have to find all the same statements. But now, with PL Scope, I can say, find all the SQL statements. So I'm going to group by SQL ID and text, and I'm going to say count star with count star greater than 1. So it's going to search for all the different SQL statements. It's going to get back the text as well, and it'll show me how many times they occur. Or I can say, show me, where do they occur? So I find all the SQL IDs that have that situation, the count is greater than 1, and then I find all the program units that have them and the line number in which they occur. So hopefully that gives you a very quick example, demonstration of how powerful PL Scope is and how much you can do with it. And in some cases, at least, how simple the solutions can be. Also take a look at use PL SQL to find SQL statements with user-defined functions. So here's a function called myFunction. Doesn't do much, returns a number. Great. Here's another one. And the thing is, inside my PL SQL code, I can call my own functions inside SQL. I can call them in the select list. I can call them in the where clause. I can call them in subqueries. Wow. Now, that's really nice because you essentially can extend the SQL language with your own application-specific functionality. What's not really nice is that there are some very important complexities. Oh, I'm just getting a note about screen frozen. Wow. Are we still just showing the more examples and you haven't even seen anything in PL Scope? Bummer. Francisco, is there anything we can do to unfreeze the screen? It looks like it's been frozen for the last 5 or 10 minutes. Thank you, Anton, for letting us know about it. I'm going to unshare and then reshare. I should have been paying more attention. So I guess you didn't see anything about the SQL statements being the same. Let's go over that really quickly. And duplicate SQL statements. So even though these statements are physically different, when they're compiled inside PL SQL, they're canonicalized into a single string, the same string, all uppercase, one line, and they have the same SQL ID, even though they're the different signatures because they're different SQL statements. And then I can say, find all the SQL statements or find all the places in my code where the SQL ID occurs more than once. And so I can very simply and easily identify places where duplications of the same SQL statement, even if they're formatted differently, as long as they have the same basic structure inside my code. So my apologies for not showing the screen for that. Let's go back and now start again with the user-defined functions. So I can declare my own functions and call them inside my SQL statements inside PL SQL or even outside of PL SQL. And it gives me a way to extend the SQL language with my own application-specific logic. I do this a lot, and I'm sure you do too. There are a couple of things to keep in mind, though, about this. First of all, whenever a SQL statement calls a PL SQL function, you get a context switch from one engine to the other. SQL and PL SQL are very tightly integrated, but there's still that switch, and that switch has overhead. So this procedure executes a SQL statement, that's one context switch, and then when it calls my function 1, it executes another context switch. Let's say I'm returning 10 rows, then there'll be 10 context switches for MV function 1. Even worse, if I call my functions inside a where clause, I might have gone through thousands, tens of thousands of rows to get 10 up here. This function and this function will be called tens of thousands of times. So user-defined functions in SQL are a great feature, but they can cause severe performance problems. The other thing to keep in mind is that in general, your functions that you call inside SQL should not contain SQL themselves. And the reason is that you can run into read consistency problems. So as I'm sure you all know, while the select statement is running, let's say it takes an hour to run. During that time, if somebody comes along and changes my data, deletes all the rows in the table, this query will not notice that difference, will not notice the change, even if it's committed, because Oracle keeps track of a read consistent image of that data from the time my select statement started. That's a really great feature of Oracle. Now, if you call a function that has a select statement inside of it, inside your select statement, the select statement in my function 1 is outside of that read consistent image. So in the outer query, you won't see any changes to my data. But in my function 1, if it does a select from my data, the next time it's called after the commit, it will see the changes that took place, like deleting all the rows. So 2 issues with user-defined functions. One is watch out for context switches, and the other is watch out for SQL inside your functions that are then called inside SQL, inside PL SQL. So what you can do is use all identifiers and all statements together to find those locations or find those procedures, find SQL statements that contain within them a PL SQL function. Now, I won't go through all the details of this query here, but one thing that's really interesting to note is I'm doing a union together, a union all, of the statements and the identifiers. And the reason I'm doing this is that the PL SQL team was very careful to make sure that the usage IDs across these 2 tables are distinct. So in other words, this might have 1, 2, 3, 4, or 1, 2, 4, 6, 7, and this would have 3, 5, 8. So you union them all together to get a picture of all the usages across the 2 different views. And then I can query from those and put it all together into a single query result. Whoop. Table of view does not exist. Oh, sorry. This is the all version. So in Live SQL, you don't have access to all views, just user views. Here's the user version down here. Whew, that scared me for a minute. So here's my output. You can see that my usage IDs go 1, 2, 3, 4, etc. But somewhere along the line, some of these, notice, reference table, this is from all statements instead of all identifiers, but I can merge it all together. And once I've got that in place, here's an example of finding all the DML statements. So here are my SQL statements. The type is select, update, delete, and gee, I guess I should do insert too. And then I find all the calls to functions. And I put all of that together. Here's the user version. And I find the objects and the statements that contain those PL SQL functions inside of them. So that's probably the most complicated thing I've done with PL Scope, but it also has tremendous benefits in terms of your ability to both analyze your code and understand different, really non-trivial ways that you might need to optimize that code and start to unwind things that you might have built. All right, I'm going to whoops. I had mentioned how you can also find dynamic SQL. So here's an example of that. In this case, I'm going to do 2 things. First, I'm going to just say find all the statements in my code that have type execute immediate or open. So these are the 2 statements that you can use to do dynamic SQL natively in your code. I can execute immediate a drop table, execute immediate a select statement. I can also say open a cursor variable for a dynamic SQL statement. So this is my native dynamic SQL search. And then this is a bit more complicated, and you'll have to talk to your admin about doing this, but you can also gather identifiers for the built-in packages like DBMS SQL. Up through 12.2, these are not automatically compiled with identifiers and statements on. So you'll have to go back and have your admin do that. And once that's been done, you can then search for all the places in your code that have a reference to the DBMS SQL package. Now, having said that, it's probably easier actually to do a text search through all source that contain DBMS_SQL dot, which would give you the references, a pretty good list of all the references to the DBMS SQL package, and union that with your all statements query, looking for execute immediate and open. Regardless, you now have a pretty easy pathway to identify all the places in your code that are vulnerable to dynamic SQL or to SQL injection. And from there, you can actually say, well, is this a SQL injection vulnerability? For example, basically, can information be passed directly from a user input directly into the SQL statement? And in general, that's what you never want to allow them to do. Because as soon as they can type whatever text they want on the screen, they can do things like semicolon and then union with users table and get user information and start phishing through your company. So this is a great way to get a head start on locking down your system and making it more secure. All right, so that's a good overview run through of PLScope and the abilities that are offered to you. I suggest that you pursue this feature with the following references. First, of course, use Live SQL. So use it generally and use it specifically to search for PLScope, find my helper package, lots of different examples of how you can write queries against all identifiers and all statements. Check out PLScope documentation. It's in the database development guide. I've got a number of blogs on PLScope, pretty much the kind of things that I just talked about, and have live SQL scripts for. Just search on scope in my blog. And last, but definitely not least, perhaps most, Philippe Salvesberg is a fantastic developer in Europe who builds really very non-trivial utilities for developers and then generally makes them available as SQL Developer plugins. And that's what you'll find here. So we have not yet had an opportunity to build a nice interface for PLScope into SQL Developer, but instead you can download his package, and it contains a number of views and a number of PLSQL packages. You can create a plugin, or you can install a plugin to SQL Developer, and you can access PLScope and all of his great utilities through the SQL Developer interface. So this should give you a really nice start on using PLScope, and I'm happy to answer any questions you might have now. And I do apologize for getting that screen frozen along the way. In fact, I'll be happy to go back and talk to you more about what you might have missed as a result. So I think we'll be taking questions through the chat room. And why don't we see if anybody's got any questions that I can answer for you? And it can be on PLScope or other topics in the world of PL/SQL. Any questions for me? All right.
Thank you so much, Stephen. And up to this point, I cannot see any question on the chat. Anyone have any question? Please feel free to post it in.
Great. I'm glad you enjoyed. And of course, as you saw, in fact, let me go back
no question, but it was a great video.
Well, why don't I just go back up the home page and make sure you get access to those resources. Yep, no questions, but just a reminder, feel free to email me. Definitely follow me on Twitter, check out my blog, and take advantage of all the resources my team is putting out for Oracle database development. We have a question. Is there any bad things?
Anthony is asking, is there any bad thing?
Yes. So the question is there any downside to setting your optimization level up to 3? Well, it's interesting you asked that, Anton. There was a time in which I recommended that you try level 3, but not necessarily make it your default, because the documentation stated that in some cases, level 3 optimization could result in sub-optimization in other aspects of your code. Basically, by inlining first, I'll explain what that means in a second, you could preclude other optimizations. I've since been updated by the PL/SQL development team, and I've written a blog post about this. Their recommendation is that you should always set your optimization level to 3. That the chance of having any negative consequences, in other words, a program unit that runs slower as a result, is very, very small. So increase it to 3. If you find certain programs that are running slower as a result, you can always turn off inlining. So level 3 optimization is about subprogram inlining. If you have a procedure within a procedure, it'll put the code for that procedure inside the actual reference to the code and basically shortcuts a lookup at runtime. But in general, you're not going to see any problems with doing that optimization, and I encourage you to do it. And there's another question, any functional faults or bugs around it? I don't know about any bugs for level 3 optimization. There are certainly some consequences you can run into, but no bugs that I know about. But I don't spend a lot of time on Oracle support looking through the bug list, so it could be that there are some there. Any other questions? All right, thanks for joining me. This will be posted online, so you can watch it anytime. And happy PL SQL coding, happy Oracle database coding. Thank you. Francisco, should I just turn it off now?
Yes, please.